Good morning. Today we are going to start with a new lesson, Graphing Rational Functions, lesson 7 in our chapter. In this lesson, we are going to learn how to graph the rational functions. Let's recall the rational functions. That's the inverse variation are an examples of rational function because the rational function has a polynomial over polynomial. And we talked many examples before of the polynomial functions, such as 3x squared over 5x, x minus 2 over x plus 3, x over x minus 2, 5 over x minus 1, and so on. These are examples of rational function, and the inverse variation are one of them, are an example of the rational function. In this lesson now, we are going to graph the rational function. We are learning how to graph this function, or this function, or this function. So if you want now to graph it, you have to understand what do you need to graph it. You need to plot the points. You need to find something we will learn about it today, which is the asymptotes. If you know where's the asymptotes, if you know where's the excluded value, if you know how we plot the points, you can graph the curve. So here now, to find how to graph any function, the first step, you have to find where is the excluded value. I mean, like, if you have it like, as an example, what do I mean? If you draw this curve here, or this line as an example, sometimes I tell you, no, stop. At point 1, it cannot be defined. So what's the meaning of that? That's mean at point 1 here, you have to put it, you have to exclude it from drawing it. So that's mean when you draw it here, it comes like this. That's mean at this point here, you have an open circle. That's mean at point 1, this angle here or this number here is not excluded. Here now we have the same, but this is the rational, this is a curve. So now let's see the first step. That's when you want to graph the rational function, you have to find the excluded points. Let's see now how the excluded points, how to identify the excluded values. To find it here.
Yes, miss.
To find it here, this is the excluded value. That means that the function is not defined at this point. Did you remember before that when we solve any rational function? Like if you have 3 over x minus 1 equals 5 over x minus 2, as an example. When you solve them, you will find that at x equal 1 is undefined, or at x equal 1, it makes the function as a 3 over 1 minus 1. When you evaluate it here, you will find that at 3 over 1 minus 1, which is 0. So this point 1, when x is 1, it makes the function, or the denominator 0, so it's make the function undefined.
Okay.
I will give you another example. If you have like 3 over x minus 5. Okay, now I want you now to find, this is the function. I want you now to find f at point 1, f at point 4, and f at point 5. Yeah, f at point 1, how it will be?
It will be teaching 3 over
3
negative 4.
Over 1 minus 5.
Yes, 3 over negative 4. At point 4, you evaluate
negative
4. So 4 minus 5, so you get as -3. And at point 5, you have it as a 3 over
3.
5 minus 5, which is 3 over 0. So look at f of 1. F of 1 is defined. You have a number. Here you have a number. But at the last one, you have it as a 3 over 0. And I told you before that if you have 0 in the denominator, this is an undefined. This is unexisted. It's not true. So which number makes it is undefined?
5.
5.
5.
So how did we find 5? Shall I try each number? No. I will go to the denominator. I will tell the denominator, come with me here. What is the 0 of the denominator? What is the number that makes the denominator 0?
5.
So we add 5. So this 5 means that if you evaluate it on the function, you will find that the function is something over 0, and this 0, it makes them undefined. So to make them, or to know which point is an excluded value, you have to find the denominator of the 0 of the denominator. If you find the 0 of the denominator, you can find the excluded value. Is it clear?
Okay. Yes.
Yes, teacher.
Let's start now here. What is the excluded value for each function? A. F of x is 5 over x minus 2. I need now to find the point that if I evaluate it with my function, I get it as 5 over 0. What I have to do, I will bring the denominator here. And I will ask the denominator, which number that makes you 0? I will make it here like this. So I find that at x equal to, I will make my function 0. So I will come back, I tell the generator, thank you so much. I will get it back. So I tell them that at x equal to, this is an excluded value. So that's mean if you try to find f at point 2, what did you get? You get 5 over 2 minus 2, which is 5 over 0, and this is undefined. So when you put a point to find the function, you can tell me, teacher, at point 1, at point 3, at point 5, at point 7, at point -1, but don't put at point 2. Because at point 2, this is an excluded value. So teacher, please be careful at point 2. Don't put or don't evaluate the function because it's already undefined. Let's go now to solve B here. For B, y is -3 over x plus 8. So now, I need now at which point this will be the excluded value. What I have to do, I bring the denominator. I put it here. I say if x plus 8, so I bring the denominator and found it's 0. After I find it's 0, which is at point -8. Did you know how to find it? -8
minus 8
minus
from 8 plus 6.
So at x equals -8, this will be an excluded value. That's mean if you try to evaluate it in our function here, -3 over -8 plus 8, it makes them as -3 over 0. It makes them undefined. So I will say, teacher, I will choose any point you want except -8. Because -8 makes my function undefined. Is it clear?
Yes, teacher.
Yes, Miss.
Okay.
Yes, teacher.
Let's have now these examples here. What is the excluded value for y equals 3 over x plus 7? So I need which point that's make them undefined. Make them undefined, that's mean make them as 3 over 0. What I have to do? I have to bring the denominator, makes them equal 0. So I find that at point -7, this is an excluded value. So really, if I try -7 plus 7, I get 0. So this is correct. Is it clear?
Yes, Miss.
teacher. Yes, teacher.
The excluded value, that's make the function undefined. You have to know what's the meaning of it and how did you find it. Now, this is the first step of graphing a rational function. Let's now continue. What we have to do next? Here now, as you see, we have the graphs of many rational functions. They are related to each other. The first one is for 1 over x. And the second one is 1 over x minus 3. Now look at the first one here. We have it as 1 over x. As we said yesterday, how is the curve of the inverse function? It has to be like this. It has to be a curve. It didn't touch the axis. For the first one here, can you tell me for 1 over x, what is the excluded value?
Teacher, there will not be excluded value.
We have. It is 1 over
0,
x.
Miss.
0,
It's
exactly.
0.
So what's the meaning of 0 on the coordinates? It's with the axis. So if you look at here, this is an axis that's at point 0. You don't touch the axis. And at point, and at the x-axis also, don't touch the axis. I told you, please don't touch it because my excluded value is at point 0. So don't touch the axis. Now look at the second one here. The second one here, you have it as 1 over x minus 3. So that's mean, if you look at here, where is the excluded value? At the 0, at the 3, exactly. So look here, what did you have? At point 3, the function didn't touch this line. If you have at x equal 3, this line here, the curve didn't touch it. So I draw I found the first step. I found where's the excluded value at point 3. So I make a line at x equal 3. Then after that, after I make this line here, it's like this. And as later on, I will give you these details. But I tell you now why I need the excluded value in the graphing. Imagine now this is the axis here, and I want now to graph 1 over x minus 2. The first step, you have to find the excluded value. Where's the excluded value?
2.
Exactly, at point 2. So if this is 1, this is 2. So I will draw now a line like this, and I will say, please, my function, don't touch this line, because I told you that this is an excluded value. So since it is rational, so I have to draw it like this. And I will say this is for 1 over x minus 2.
Teacher, it will not touch what?
This line.
The 2?
Yes.
Okay, but no problem if it touch the y-axis.
Sometimes there's a problem, sometimes no. But this is not, sometimes you can make it like this. But later on, I will tell you about this. But this is the first step here, that you have to know that at point 2, don't touch my curve. Please don't touch it, because this 2 is an excluded value for you. Don't touch it. Don't reach it. This is the meaning of the excluded value.
Okay.
Okay. So now, this is here for 1 over x. This is here for 1 over x, and this is here for 1 over x minus 3. For 1 over x, as I told you, the line that I tell my function don't touch it is this line. And the line for the second one that I tell them don't touch it, don't reach it, it will be at x equal 3. So if you look at them, what is the relation between the first and the second function?
That teacher, the first function, the excluded value is 0. The second function is at 3.
Yes, but what's the relation between them? Can I see that the second function is translated 3 units to the right?
Yes.
Yes. So here
Yes.
we ought to draw it. That's mean this is draw 1 over x and translate it 3 units to the right. This is the relation between them. Now, so let's come back here. So when I find the excluded value at point 3, I draw a line at 3, and I told my function, please don't touch this line. So what is the name of this line? Let's see. The name of this line, we called it asymptote. What we call it? Asymptote. What is the asymptote? It is a line that a curve approaches as it head towards infinity. That's the curve didn't intersect it, didn't touch it. This is my curve in the blue line here. Oh, this is the curve here. And the asymptote is a line that didn't intersect it, didn't touch it. But it will touch it at the infinity. But I didn't see this intersection. But in my curve here, in my given area, it didn't touch it, didn't reach it. So that's why when I find the excluded value, I draw the line that's of the excluded value. I told them this line, it makes you undefined. When I draw the curve, I will say stop, don't touch this line, don't intersect it. This line, we called it asymptote. So the asymptote of a curve is a line which is tangent to the curve at the point of infinity. At my given area, I didn't touch it, but its infinity, it will touch it. In modern meaning, it means that the line that does not intersect the given curve, does not intersect the curve. It touches at the point of infinity. Its approach to it. Its approach to it seems to be close to it, but it didn't touch it. It didn't intersect it. This is the meaning of asymptotes. Is it clear?
Miss Teacher, this asymptote is the same line that we draw it for the
Yes.
excluded value.
Yes, exactly.
Okay.
Let's have now more examples here. Sorry, before that. You have to know that we have 3 types of asymptotes. 2 of them are included with you, the horizontal and the vertical. This is important for you. The horizontal asymptotes, that is asymptotes that is parallel to the x-axis. We call it horizontal asymptotes. And the vertical asymptotes is an asymptote that is parallel to the y-axis. This is the x and y axis here. Now, the line that is parallel to the y-axis, we called it vertical asymptotes. And the line that is parallel to the x-axis, we called it horizontal. That's why when you come here at 1 over x, we found that the x-axis is an horizontal asymptote and the y-axis is a vertical asymptote. For the second one, we found that here at x equal 3 is a vertical asymptote, and at the x-axis or at x equals 0, this is an horizontal asymptote. Later on, you will see how to find them. That's just here an introduction. Just from here now, from you, I want you to now to learn what is the meaning of asymptotes and what are the 2 types of asymptote, horizontal and vertical.
But teacher, why we didn't draw it? Yes.
Yes.
Why we didn't draw it, teacher, as a curve? If we want to find the excluded value and to graph it, we will draw it the asymptote in a graph way, in a curve way.
In the function is in a curve, but the asymptote as a line.
Okay.
Okay, let's have these examples here. Look at A here. In A here, as you see, where is the vertical asymptote? Sorry, the horizontal asymptote. At y equals
0. No.
1.
The vertical at, yes, y equal 1, yes.
So the horizontal asymptotes at y equal 1. This is the horizontal asymptotes. The horizontal asymptotes, it's parallel to the x-axis, but I write it as y equals something. Now, where is the horizontal asymptotes? This here. This is the line that didn't touch it. So this line at x equals 0, we called it vertical asymptote. Now look at B. In B here, where is the vertical asymptotes? Miss, this is vertical and this is horizontal. Where's the vertical asymptotes?
X equal, teacher, the second one.
Yes, one at B. Where's the asymptotes?
The asymptote at -1, miss.
At 1. At x equal 1, we have the vertical asymptotes. Before vertical and horizontal. So at x equal 1, this is an asymptote. Now look at C here. At -1, this is my asymptote. And also at 0. at the x-axis. Here at the x-axis and at, oh, we have the same example here. So these are the examples. Yeah?
Teacher, I got confused.
Why?
I have a problem, teacher, in finding this asymptotes.
Here, did you see this line? This line here, this is the asymptotes. Before vertical horizontal, let's look at the asymptotes, the meaning of asymptotes. The line that's where the curve didn't intersect it is an asymptote. So this line, the pink one. And the second one here, where's the asymptotes? Is it this line? Or this line?
No.
Look at this one here. This line here didn't intersect with the curves. So this will be an asymptote. Yes. Look at the third one here. This is the line. This line didn't intersect the curve. So this is the asymptote. This line didn't intersect the curve. So this will be an asymptote.
Okay.
Okay. So here, from here, where's this is the asymptotes. The asymptotes, that's where's the curve didn't touch the line. Or where the curves didn't touch the line, yes. Let's have this example here now. Now here, where's the asymptote? Let's draw it. Yalla, search about a line that's, if you draw it, they didn't touch the two curves.
At teacher 0.5.
0.
I mean half.
At point -5 here. At this axis. At the y-axis, as you see, the curve didn't touch the axis, and at point -5, the curve didn't touch this line. So we have two asymptotes at y equals -5 and at the y-axis. So I want you now to look at number 2 here. Where is the asymptotes?
The y-axis and the x-axis.
Bravo, the y-axis and the x-axis. So here we have the asymptotes. Didn't touch it. And here. Now, this example here. Where is the asymptotes? Where's the line that didn't the curve touch it?
2 and -2.
2 and -2. This is the meaning of asymptotes. I don't want you to find it. Just what is the, did you need, what is the meaning of the asymptotes?
Yes, miss.
The asymptotes didn't touch the curve.
Yes, teacher, here there is an x-axis asymptote. Yes, this word.
Asymptotes, you mean? Yeah, in this example, no. Because for the first one, it didn't touch it, but for the second one, it touched it. This is a complicated one. Don't look at it. This is a complicated one, but just here an examples of the asymptotes of the horizontal. So just from you, I want you to understand what is the meaning of the excluded value and what is the meaning of asymptotes. Asymptotes didn't intersect the curve. And the excluded value, the points that make the function undefined.
Teacher, in asymptotes, like teacher, I have here the graph. Like if teacher, the graph touch the x-axis, but it is not near from the y-axis. So I will count how it is far, and if the distance between the graph and the y-axis to see the asymptotes, asymptotes.
Asymptote, yes. And first of all, like what? Like here. Do you have an example here? Hello, Miss, here I will not give you a graph and I'll ask you where's the asymptotes. Here, just I want you to know what is the meaning of asymptotes. That's I need them when I want to graph. That's as an example for this example here. I need to find where's the excluded value. That's when I want to graph, I will plot the line that is the asymptotes. And when I want to draw, I will say, don't touch this line. That's it only. So what I need from you just to understand what is the meaning of asymptotes and how did you find the excluded value. Are they clear for you?
Yes, miss.
The other things don't expand your thinking. Like if I have something or if I have or just a line. That's if you have the axis here, the line, that's I draw it here, and my function didn't touch it. This is an asymptote. If sometimes you have it like this, here it's tend to touch to, and it's very close to the x-axis. So I will say at x equals 0 is the asymptote. Sometimes you have it like this. Like at point 1, oh sorry, at point 1, I could have my asymptotes. So the line of the two curves would be like this. As an example, like this. This one mean here that this is the line will be the asymptote. The curve of the line, whereas my curve didn't touch it.
Teacher, the both curve. And the graph.
The both curves, yes. Oh.
Okay.
Now, let's see now here in this example why we need the vertical, or why we need the excluded value, and why we need the asymptotes. The first step here, look at my function. It was 5 over x plus 2. So the first step, find the excluded value. To find the excluded value, I look at the denominator. At x equal -2. This is the excluded value. So this is when x is not -2. That means I will go at point -2 and I draw a line. Did you see it now? This line is an asymptote. So when I find the excluded value, I can draw the asymptote.
Oh, teacher, so the asymptotes will be at the excluded value.
Yes, that's it.
Okay.
Okay. I find the excluded value Where's the excluded value? I will draw the asymptotes. Then you plot the points like this. They put a point such as -7, -4, -3, -1, 0, and 3. And then they evaluate each point on the function here, such as at point -7. We have to say 5 over -7 plus 5. At point -3 as an example. 5 over -3 plus 2, sorry. A third one, 5 at 3 plus 2. Just evaluate x here with -7 and -3 and 3. At point -7, 5 over -5, which is -1. At point -3, you have it as -5. And at 5 over 5, 1. So after we plot, I have the x-axis, the x points. After we make a table, we have defined the y-axis. Now then let's draw. At -7, we have it as -1. At -4, we have it as -2.5. At -3, we have it as -5. We draw the first curve. Now be careful. At point, I mean that I put a point such as -7, -4, -3, and I skip -2. Because at point -2, it's undefined. So at point -2, I don't put it in my table. Then I will continue. -1, 0, 1, 2, 3, and so on. So when you draw your table, put all the values except -2. Then at point -1, we have it as 5. At point 0, we have it as 2.5. At point 3, we have it as 1. Connect now between this, you have the other curve. So after you draw the two curves, you will find at point -2, it didn't touch